Okay, hey everybody, this is going to be Unit 4, Day 1, Part 2. Anybody that thought that I could do that in 15 minutes, I guess you're saying, told you you couldn't, Mr. Conway, you talk too much, and you're probably not wrong. All right, so I think I left off at subliminal stimulation, okay? I get a lot of questions about subliminal thresholds. What's kind of interesting about subliminal is the definition is it's under our conscious awareness, meaning we have no idea that it's happening. A lot of times people believe that you've probably heard of subliminal messages being snuck into things like commercials. Disney is always being criticized for having inappropriate subliminal messages to um, try to traumatize kids and things like that. Big conspiracy theory, but you can decide for yourself. But other things like army commercials, some people think that a lot of pop culture says that the military uses subliminal messages to try to brainwash and to recruit people into becoming members. So what it would be is like under your conscious awareness, they would send messages like join the army, do it, you want to, like it's going to be, to try to persuade you, but it's under your awareness, so you don't even know this happening. So let's say you'd be like, oh, I'm never going to join the army, I don't want to do that, but they feel like if they kind of, a lot of times people, it happens in their sleep, they're almost being hypnotized or something like that. So that's what subliminal is. But the thing is with subliminal messages is the second that we detect it or realize it's there, it's no longer subliminal. So people are like, "Oh, I saw a subliminal message," or if you see it, if you notice it, it's not subliminal. It can't be in your conscious awareness. So it's pretty hotly, it's a hot topic. A lot of people don't think that it's really true, but feel free to check it out for yourselves. The next thing you're going to look at is about priming. So this doesn't have to deal with prime numbers or math. What this means is when you're priming something, you may have heard the expression you need to like prime the pump or prime something. And it means you're getting it ready. If you prime something, you need to prime I don't know, you can think of anything. Prime the oven, like preheat the oven. So what priming is would be somebody preparing you to react a certain way unconsciously. So if I were to, like, if you've ever heard the joke, it's not really a joke, but you get somebody to say, I don't know, hop 5 times, and so they go hop, 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 and then you go, what do you do at a green light? And then somebody goes, stop, and it's like, no, you go. But what I did was I was priming you to say something, but you weren't really aware of what I was doing. You were just saying stop. So priming could be, um, I'll show you an example in class of priming. Okay, next one. This has a very powerful image with it. Okay, so another um, difficult topic is difference threshold. What is it? I have absolute and now I have difference. How do I know the difference between the two? Okay, so remember, absolute is when the minimum amount of stimuli needed for you to actually detect it and tell that it's there. So before that amount has been met, you don't even know that stimuli is there. Difference threshold, though, you're aware that it's there. You see it, you hear it, you smell it, you taste it, you feel it. But at some point, if that stimuli changes, then what we have now is a difference. So, for example, it's sometimes called the just noticeable difference. And I want you to look at the picture on right below difference threshold. I don't know what page it's on. Ebook says printed page 120, but it's probably a little bit past that. Okay? So it is the one where it starts off saying, the Lord is my shepherd. And I think you'll notice that if you look at that first line versus the last where it says forever, the font has gotten bigger. So hopefully you can see that from where it says the all the way down to forever, it's gotten bigger. So at what point can you 100% say that you can tell that the font has gotten bigger? And don't even pick that second or third one. Okay? It's probably at like he restoreth or he leadeth, something like that. I know, sorry for the psalm. This is just what the book gave us. Um, but you'd probably believe me if I told you that it started getting bigger from that second line where it says I shall. Okay, but it's hard to tell if it's getting bigger. You can't tell for certain. If you didn't see it bigger at the bottom, you wouldn't know, excuse me, that those two are any different. So the difference threshold then would be wherever you can tell the font got bigger. So you see it. So your absolute threshold is definitely there. Like you detect that because it's really close. And you notice that there's a difference, small at the top, large at the bottom. The just noticeable difference or the difference threshold is trying to identify where that difference occurs and where it takes place. And so that can be tough sometimes. Think about like with recipes, sometimes you got to add something like sugar. So you drink some sweet tea and it doesn't taste sweet. So you keep adding sugar, you take a sip, oh, it tastes the same. Well, you're putting more sugar in, but you don't taste anything. So that difference threshold has not been met yet. So you put another spoonful of sugar in, and there, voila, all of a sudden you taste the difference. Another example you can use is volume. Okay, you're in the car, or even the TV. If somebody says turn up the TV, usually the TV volume goes from like 0 to 100, right? If somebody says turn it up, do you just click 1 on the volume? Or if you're in the car, do you just turn the volume up 1? Is that really going to be noticeable? Yes, it's louder, but we kind of just know that because we turned it. Can you actually hear it? And probably not. So you would have to, a lot of times when you turn it up, people turn it up in increments of 5, 10, before you. I know when I turn the volume up, I'm not just gonna turn it up one notch because I can't tell a difference. So my difference threshold for volume is maybe like 3 to 5, maybe 10. It just depends. So you could probably, without somebody noticing, if you're in the car, if the volume was down real low, you could turn it up one small increment at a time, and they wouldn't notice until the song is literally blasting. That could be inattentional blindness, that could be selective attention, but it's also going to be their difference threshold. They're not going to know, and you'd be laughing saying, "I've been turning this up for like 5 minutes, and you just now noticed." So wherever they notice that difference, oh wow, it's louder, or oh wow, I really taste the salt that you added. That's going to be the difference threshold, or the just noticeable difference. Um, and the other thing, before we get into, we got a couple more things before we get into that vision. There's a law that goes with difference threshold. Okay, this is really cool. This took me years to be able to explain. I remember teaching this my first year and just being like, "This is Weber's law." I hope nobody asks me about it, because I don't really know how to explain it. But luckily I do now. So you need to pair Weber's law with the difference threshold. Okay. Weber's law says that when we it's all about comparing differences. When we compare this difference and this difference, what it's saying is that we must use a percentage rather than what do they put it in the definition? Did they say, okay, rather than a constant amount? What does that mean? Glad you asked. Let's use an example with weights, okay? Humor me. Let's compare the difference in weights with a 5 and a 10-pound dumbbell, something that you would do curls with, or whatever you want, and the difference between a 100-pound weight and a 105 pounds worth of weight. So we're comparing 5 to 10, and then 100 to 105. Okay? Let's look at the constant difference, what that means in the definition. That would mean like the pound for pound difference. So what's the pound for pound difference between 5 and 10 pounds? I'll let you do the math. Okay, time's up. You take 10 and you subtract 5 and you get 5. Okay, so the constant or the pound for pound difference is 5 pounds. All right. Well, do you think that you would notice a difference between 5 and 10 pounds? You probably would. Even if you're really strong, You would probably notice a difference between picking up 5 pounds and 10 pounds. Well, why? It's a 5 pound difference. Let's look at the percentage. What's the percent difference between 5 and 10? Okay, time's up. It's 100%. You take 5 and you double it, it means you're adding another 5. That's 100% difference. That sounds like a pretty big difference. So yes, you would notice if something changed 100% or if the weight increased 100%, you would definitely notice it. Let's go back to the heavier weight. If you could lift it, do you think that you would notice a difference? If you lifted 100 pounds, something really heavy, and then somebody added a teeny tiny 5 pound weight to it, do you think you would notice the difference between 100 pounds and 105 pounds? You probably wouldn't. It's pretty heavy, and it's not, you know. But let's Weber's law. Okay, so why are we talking about this? Well, let's compare the two differences. You'd probably feel the difference between 5 and 10, but you wouldn't feel the difference between 100 and 105. Well, what's the pound per pound? There it is again. Pound for pound difference. Take 105 minus 100, and you get 5. Well, that's the same as the difference between 5 and 10. So why can't we feel the difference between 100 and 105 if we could feel it between 5 and 10? Oh, well, Weber's law says that we must, when comparing those differences, right, we have to look at the percentage difference, not the constant. So we can't compare the difference between 100 pounds and 105 pounds with the difference between 5 and 10. We just can't. So what we have to do is we have to look at the percentage. So 5 to 10, you told me, is 100% difference. What's the percent difference between 100 and 105 pounds? 5%. So what we're actually comparing is not pound for pound. I said it right that time. We're comparing the percentage. So the reason why you feel a difference between 5 and 10 pounds more than 100 to 105 is because the 5 to 10 has a 100% difference. That's pretty big. While the 100 to 105 pound only has a 5% difference. We probably wouldn't feel a 5% difference. Okay, think about it in money as well. If somebody took 5% out of your paycheck, if your paycheck wasn't the same every month, you'd probably not notice it if they were taking 5% more out for taxes. You may, but you probably wouldn't. Now, if they took out 100% more, yeah, you would absolutely notice it. So when we're looking at differences, we have to look at percentages and not just the constant. This is 2 videos in, and I'm already getting to the end. Okay, good thing there's really only one more thing, and then I'm just going to have to do the eye tomorrow. So a very popular test question is about sensory adaptation. Luckily, we get this. This is something that comes naturally to us. So sensory adaptation says that you get used to stimuli the longer you're exposed to it. So think about this. Have you ever been away from your home for a few days, and then you come back and you notice that your house has a smell? Maybe it's good, maybe it's bad. Or you go into your room and you're like, oh, wow, my room smells like something. Or you come home and somebody's cooking and it's like, wow, that smells really, really, really good. You go to your room, doing your homework, and you come back down 20 minutes later and you're like, I don't really smell it anymore. Or let's say you live near the airport, you've got a new house, and you just notice all those planes flying by. How does anybody ever live here? It's so loud. Stay there for a few days and you're not going to notice the planes anymore. You get used to it. You adapt to it. Your senses literally adapt. Sensory adaptation. It's a survival technique so that our senses are ready to detect anything that changes. So the reason why we don't smell the smell of our house all the time is so that we can actually be ready if we smell a gas leak or something that's going to actually harm us. Okay? If we were just always smelled, the same old stuff, then if there was a threat in our environment, we wouldn't be able to do it. So sensory adaptation is just getting used to something. Whether you're used to living near somewhere and the sound, you can tolerate it, or you don't smell it. There's a question on the test about somebody moving in next to a bakery, and they used to smell all the lovely sweets and breads, and after a few days, they don't smell anymore. That's sensory adaptation. So see if you can think of a couple more examples for all 5 your senses at 15 minutes.